Today I'm going to start with a new topic, that is signed binary numbers. Okay. So here you're going to learn how to represent signed binary numbers. So first of all, let me explain you what are signed binary numbers, and then we'll see in what way you can represent signed binary numbers. So signed binary numbers, what are they? Basically, in decimal number system, we use minus sign or plus sign in front of the number to donate, to express the number either as a positive number or a negative number. This representation of number is known as signed number, which means when the numbers are associated with sign, either a positive sign or a negative sign, this kind of representation is called signed number representation. Okay. But in digital systems, you see there is no provision made to put plus or minus sign to a number, since digital systems operate on binary numbers that are represented using only ones and zeros. So the question is how to represent signed binary numbers if all we have is a bunch of zeros and ones. So suppose you have to represent a signed decimal number, how will you represent that decimal number in binary form is a question. So normally an additional bit is used as the sign bit and is placed as the most significant bit. And if the value of this bit is 0, it represents a positive number, and if value of this bit is 1, it means it is a negative number. Okay. This is how we show positive and negative number in binary number format. Okay. So there are basically three ways to represent signed binary numbers, and they are sign magnitude form, ones complement form, and two's complement form. So we'll look at each of these forms of representation of signed binary numbers in this class. So let us start with the sign magnitude representation. Sign magnitude representation. So as I said, in a signed binary number system, we add an additional bit which is placed as a MSB bit, and by looking at the value of this MSB bit, we decide whether we come to know whether the number is a positive number or it is representing a negative number, right? So the MSB bit indicates sign of the number, and the remaining bits gives the magnitude of the number and is written in pure binary form. Okay. So thus if we have n bits with us, okay, then we divide it into two parts. The first bit indicates sign of the number, and the remaining n minus 1 bits, is used for finding the value of the number, gives the value of the number or the magnitude of the number.
The screen is frozen.
What screen is? Oh, I see.
Frozen.
I'll just wait. Yeah, sure. Yeah, is it now visible?
Yes, ma'am.
Yes.
Yeah. So I was saying in the sign magnitude representation form, the MSB bit indicates the sign of the number and the remaining bit gives the magnitude of the number. So if you have n bit binary number in sign magnitude form, the first bit indicates the sign of that number, that is the MSB bit indicates the sign of the number, and the remaining n minus 1 bits gives the value of that number. As an example, for example, +5 in sign magnitude form will be 0, 1, 0, 1. So the first bit, that is the MSB bit, is 0. It means number is positive. So when MSB bit is 0, it means number is positive. Yeah, it's positive. And as I said, when the first bit is 1, it means number is negative. So the first bit or the MSB bit is indicating the sign of the number. So it is 0 here, so it means it is a positive number. And the remaining bit tells the value of the number. Okay. How do you find out value of this binary number? You have 101 in binary. Its value in decimal is, you know how to calculate. You have to multiply each bit with its corresponding weight and then add. So it is 2 raised per 2, 4 plus 2 raised per 0 is 1, that is 5 in decimal. Right? So it means 0101 in binary is plus 5 in decimal. To represent minus 5 in sign magnitude form, minus 5 in sign magnitude form, you just need to change the MSB bit value. As I said, if the MSB bit is equal to 1, it indicates negative number. So instead of 0, I will write 1. So 1101 has 1 in the MSB bit, which means it is representing a negative number, and the value of number is obtained by finding the magnitude of remaining bits. Okay. So it means 1101 is minus 5. It is representing minus 5. Okay. So minus 5 in sign magnitude representation is shown as 1105. Written as 1105. Okay. So first bit is telling the sign. If it is 1, it means it is a negative number. If it is 0, it means it is a positive number. Remaining bit tells the value of the number. Since it is 101, which is binary equivalent of decimal number 5. So this means 1101 is representing minus 5, decimal number minus 5. Okay. Let's take few more examples. Let's say plus 12 in 8 bits. Let's see how to write plus 8 in using 8 bits. Okay. So now we have to use 8 bits. Plus 12, you know, how do you write plus 12 in a straight binary form? We know that weight of binary number is 1, 2, 4, 8, 16, 32 like that. Okay. So if you want to write 12, we'll put 1 under 8. So 12 minus 8 is 4. Then we'll write 1 under 4. And at rest places we'll put 0. So 1100 is 12 in binary actually, right? So let us write plus 12 now. The sign, this is how we write it 12 in normal binary form. So plus 12, if you have to write in 8 bits, it will be 0, 0, 0, 0, 1, 1, 0, 0. This is in 8 bits. Okay. Now you see here, to find the value of this.
Ma'am, your
So
screen
it
is
is for 12.
Ma'am, we can't hear.
Okay, just a second. I will stop and then again I will start. I'll again start presenting. Can you see the screen now? And can you hear me? Am I audible now
Yes,
clearly?
Yes.
yes, ma'am.
Okay. So plus 12, if you have to represent using 8 bits, it will be 00001100. So MSB bit is 0, indicating that it is a positive number. And if you find decimal equivalent of the rest of the bits, it will be equal to 12. So this is how we write plus 12 in sign magnitude form using 8 bits. Minus 12 using 8 bits. We have to write minus 12 in sign magnitude form, and it is said that you have to use 12 bits. How you will do? You just write the MSB bit, replace MSB bit by 1. Okay. When the MSB bit is 1, it indicates negative number, and rest of the bits will remain same. So this is MSB bit is 1, it means it is a negative number, and rest of the bit is giving the value which is 12 in decimal. So this 10001100 is representing number minus 12, decimal number minus 12. I suppose it is clear. Let us take one more example. Let's say plus 68, decimal number plus positive 68. And let's say you have to represent this again in 8 bits. Using 8 bits you have to represent. How will you represent? So 68 in binary. How do you write 68 in binary? So let me write weight here. Weight for binary. 1, 2, 4, 8, 16, 32, 64. You want to write in 8 bits, right? So 1, 2, 3, 4, 5, 6, 7, 8, 1, 8. Okay. Now let us put ones and zeros under the weight. So 68. So we'll put 1 under 64. 68 minus 64 is 4. So we'll write next one under 4. And at all other places, let us put 0. So this is binary equivalent of number 68. So 68 plus 68, like 0. Plus 68 in 8 bits is 0, 1, 0, 0, 0, 1, 0.
And screen is frozen.
I think there is delay. Okay. So this is how we have found binary equivalent of 68. So plus 68 using 8 bits will be like this. Okay. The first bit is 0, which means it is indicating that we are representing positive number. And if you find value of this number, we have already seen it is 68, right? So this is sign magnitude representation of decimal number plus 68. Now minus 68 in sign magnitude form will be, instead of 0 here, I will replace MSB bit by 1 and rest of the bits will remain same. First bit, which is indicating sign, it means it is a negative number because MSB is 1. Rest of the bits is indicates giving the value of the number, which has to be same 68 because we are representing 68 only, right? So rest of the bits I have kept same. So this is sign magnitude representation of decimal number minus 68. Is this clear up to this point?
Ma'am, won't people
Yes.
confuse with 196?
With 196.
68 plus 128.
Ha, no. See, if you want to write plus 196, we cannot say this is 196, because when you have to represent plus 196, the MSB bit should be 0. What is your MSB bit? MSB bit is 1. It indicates that it is a negative number, not a positive number, first of all. So it is not going to get, it is not going to create any confusion with plus 196. The moment I say plus 196, I require one more bit. I cannot write plus 196 using these many bits, using 8, these many bits. Okay. Is that clear? This is negative number. This is negative because MSB is 1 indicates negative number. If you want to write plus 196, it will be 11000100 and then one more 0 over here. This is what is plus 196. Okay. Because this will
And
give
so
the
for this
magnitude.
negative digit, we have to replace it by 1.
Yes, for negative digit, negative decimal number, MSB bit has to be 1.
Okay.
And that's why I said we are going to use one additional bit, which will represent the sign. Now, how to find out how many bits you have to use to represent any particular decimal number, I will come to it in some moment. Okay, but I suppose it is clear how we are representing numbers, right? Okay, so let us do reverse also, and then I will show you how to find out how many bits you have to use to represent any number. Okay, let us do the reverse work also. Let's say you have to find out decimal equivalent of a binary number, which is represented in sign magnitude form and is given as 101100. Suppose this is the number, binary number sequence that is given to you, and it has been said that this is in sign magnitude form. See, users will already be knowing which kind of representation is used to represent the numbers. Okay, so it is in sign magnitude form. Okay. Let's say it is already given that it is in sign magnitude form. So which decimal number it is representing? So to find out what is the decimal equivalent of this number, you have to first of all check the MSB bit. MSB bit is 1. It means this binary number is representing a negative number. Okay, because sign bit is 1. Because sign bit is 1 or MSB bit is 1, it means it is representing a negative number. In order to find out what number it is representing, what is the value of the number that is being represented, to find the magnitude, as I said, the rest of the bits, remaining bits tells the magnitude. So you find the decimal equivalent of this remaining binary sequence. That means you have to find out magnitude of 01100. 1100, we know it is decimal equivalent of, this is equivalent to decimal number 12, right? You can find that. So it is 8 plus 4, that is 12, right? So this is equal to decimal number 12. Decimal number 12. So this means that 101100, when it is present in sign magnitude format, this binary sequence represents decimal number minus 12. Am I clear? Is this clear to all?
Yes, ma'am.
Let us take one more example. Example 2. Let's say the binary number is given 0111. Okay? And it is said that it is in sign magnitude form. Okay? So how will you find out which decimal number it is representing? You have to check the MSB bit first. Now here MSB is equal to 0, which means number is positive. Okay? Now this is representing a positive number because it is starting with 0 bit. Okay? And to find out the magnitude of this number, you must find the decimal equivalent of the remaining sequence of binary. That is 111. So 111 in binary is equivalent to decimal number 7, right? So therefore 0111, this sequence is representing decimal number plus 7. Because MSB bit is 0, so it is indicating that the number is positive, so we are representing plus 7 number, right? Example 3. Now you tell me decimal equivalent for this binary number. This is the binary number given in sign magnitude form. What is the number?
Minus
-7.
-7.
-7. Although it appears as if it is representing plus 15. It is representing 15, right? We know that binary equivalent of number 15 is 1, 1, 1, 1. But it is not representing, since it is said that it is in sign magnitude form, it is not representing number 15. It is representing number -7, because the MSB bit is 1, which means it is representing negative number, and the magnitude is 7. So it is representing -7. Okay. I hope it is now clear to all of you how to represent decimal number in by sign magnitude form, and how to find out which decimal number is being represented when the binary sequence is given in sign magnitude form, right? Okay. Now let us look at one of the drawback of this form of representation. Okay. Although it appears to be it's very simple way to represent negative number. Okay. But the problem with this representation is that there are two ways to represent 0. How will you represent 0? Number 0. Okay. Let's say we want to represent it using 4 bits. Okay. So 0 can be represented, 0, decimal number 0, we can write it as 0, 0, 0, 0 in 4 bits. And we can also write it as 1, 0, 0, 0 in 4 bits. Right? This becomes plus 0, this becomes minus 0. Right? This is in sign magnitude form. So there are two ways to represent decimal number 0, which doesn't make any point. 0 is 0, right? We do not need two different code words to represent decimal number 0. But with the sign magnitude form, we can see that 0, we can write plus 0, we can also represent minus 0. If we write MSB bit as 0, this becomes plus 0, and when we write MSB bit as 1, it becomes minus 0. So there are two forms, two ways to represent decimal number 0, right? Which is actually wasting one of the code word. One code word is just getting wasted because we do not actually need two ways to represent 0, right? Also, it may create problems while doing arithmetic. It may be, it may create some problems, right? So therefore, we go for other forms of representations. Okay? But before I move to ones complement representation, let us also look at the range of numbers which can be represented using n bits. Okay. Now, hello. I think.
Yes, ma'am. Screen is frozen.
Hello.
Hello.
Am I audible? Can you people hear me?
Yes, ma'am.
Yes,
Yes,
sir.
ma'am.
But screen is
Okay,
frozen.
because I am getting the message trying to get the network.
Yes.
Okay. So in sign magnitude representation form, you have learned that, we have seen that the first bit represents the sign bit, the sign of the number, and remaining bits gives the magnitude. Okay. With the unsigned binary numbers, a normal binary number representation, what you have learned, if you have, I'm talking about unsigned now, then I'll again come to sign magnitude form. For unsigned binary numbers, that means when we are not concerned about sign of the number, right? We have seen that if you have n bits with you, how many numbers you are able to represent? You are able to represent 2 raised to power n numbers, right? We were able to represent 2 raised power n numbers. So with n bits, you have 2 raised power n code words, unique codes, right? Which means that with n bits, if you want to go for unsigned binary representation, the decimal numbers, the range of decimal numbers which you can represent will be from 0 to 2 raised to power n minus 1, right? With n bits, you can represent 2 raised to power n different numbers. Okay. For example, if you have 3 bits, okay, Let's say n is equal to 3. Okay, so you can represent 2 raised to power 3, which is equal to 8 numbers, right? So the range of decimal numbers which we could represent using 3 bits was 0 to 7, right? Isn't it? So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 1. So 0 1 2 3 4 5 6 0 1 2 0 1 2 3 4 5 6 and 7, right? So with 3 bits, we could represent decimal numbers from 0 to 7 if we use unsigned binary numbers, right? This was the range that was that is possible with n bits, right? So 0 to 2 raised to n minus 1. Okay. But now when we are talking about signed magnitude form, we know that 1 bit is reserved for indicating sign and the remaining bits are telling the magnitude. So we have 1 bit less actually, right? So the range of numbers that can be represented using signed magnitude form will be from minus 2 raised to power n minus 1 minus 1 to plus 2 raised to power n minus 1 minus 1. With unsigned binary number, you have learned that with n bits you can represent 2 raised to power n numbers, right? You will have 2 raised, you get 2 raised to n different code words. But with sign magnitude form, we know that 1 bit is reserved for sign, right? So therefore, number of code words that are possible, okay, will be 2 raised to power n minus 1. So you have total numbers that can be represented is 2 raised to power n minus 1. Positive numbers and 2 raised to power minus n negative numbers basically, right? These many positive numbers and these many negative numbers. These many positive numbers, these many negative numbers also, right? 2 raised to n minus 1 negative numbers also. Okay? These many positive numbers and these many negative numbers, isn't it? So which means that for n bit, maximum positive number which can be represented in sign magnitude form will be 2 raised to power n minus 1 minus 1 is the maximum positive number that you can represent, because we are including 0 also, right? So the range will be 0 to this and minus 2 raised to power n minus 1 minus 1 to 0. Is this clear to all of you what I am saying? In other words, to understand this is to say that, you see, earlier with the unsigned binary number, with 3 bits, we could represent total 8 numbers, right? 0 through 7. Okay. But now with sign magnitude representation, we know that one first bit is reserved. It is for sign. It means half of the numbers will now represent positive numbers and half of this complete block will represent negative numbers. So we are just dividing it into 2 parts in short. So half is indicating positive number with MSB bit 0 and the numbers with MSB bit 1 is indicating negative numbers, right? So unlike, unsigned binary number where you were able to represent 2 raised to power n numbers, now you can represent half of this, 2 raised to power n by 2 positive numbers and 2 raised to power n by 2 negative numbers, right? Something like this. So which means, let me just come here, which means 2 raised to power n minus 1 is the maximum positive number that you can represent. This is the range. So the range of decimal numbers which can be represented using sign magnitude form will be from minus 2 raised to n minus 1 minus 1 to plus 2 raised to n minus 1 minus 1. Why minus 1? Because there is minus 0 also. It is possible to represent minus 0 also using this representation, right? So one code word is used for minus 0. Similarly here, why minus 1? Because we are assigning one code word for plus 1 also, plus 0 also. So the range is from minus 2 raised to n minus 1 minus 1 to plus 2 raised to n minus 1 minus 1. I suppose it is clear. Any doubt in this?
No,
Ma'am,
Mm-hmm.
ma'am,
Yes. Yes, yes.
ma'am, zero should be counted in the positive numbers, right? Because
0
if you
is
want to
counted
count,
in both. Because 0, there are two ways to represent 0. Positive way, positive 0 and negative 0. As I said in, you see.
ma'am, but the positive and negative with zero doesn't mean anything. So,
Yeah, it doesn't mean anything. That is the drawback of this form of representation actually. But if this is the kind of code word that appear, what will what will you say? What is this? It is minus 0,
okay.
isn't it? If this is the binary sequence that appear, what will you say? It is plus 0. Because there are two ways exist to represent 0. Therefore, here in the range, I have used minus 1. Because one code word is used for representing plus minus 0. Right?
Okay, ma'am.
Yeah, okay. So unlike unsigned binary number, wherein with n bits, the range of decimal number that you could represent was from 0 to 2 raised to power. So for unsigned numbers, range was from 0 to 2 raised to n minus 1. For signed magnitude number, the range will be from minus 2 raised to n minus 1 minus 1 to plus 2 raised to n minus 1 minus 1. Clear? Let's say we want to represent number plus 13, okay, in sign magnitude form. Let's say we want to write this in sign magnitude form. Okay. So how will you decide how many bits to use to represent number 13? We know that with sign magnitude form, the range is 2 raised by n minus 1 minus 1 to 2 raised by n minus 1 minus 1, right? So if I take n equal to 4, okay, what will be the range? What range of numbers can be represented with 4 bits? When n is equal to 4, it will be minus 2 raised to power 4 minus 1 minus 1 to plus 2 raised to power 4 minus 1 minus 1, which means 2 raised to power 3 is 8, 8 minus 1 minus 7 to plus 7. So this means that plus 13 in sign magnitude form cannot be represented using 4 bits. You require at least 5 bits to represent plus 13. You can represent plus 13 using more than 5 bits, but at least 5 bits are required because with 4 bits, the range of numbers which can be represented is from minus 7 to plus 7. So this doesn't fall under that range, right? So we require 5 bits. Okay. So plus 13, in unsigned binary form, plus 13 13 in unsigned binary form can be written using 4 bits. 1101 is 13, right? But in sign magnitude form, when you want to represent 13, okay, you require one more additional bit. You require at least 5 bits. With 4 bits, you cannot represent because the range of numbers which can be represented using 4 bits is plus minus 7 to plus 7 only. So this plus 13 doesn't fall under this range, right? So we require 5 bits. So plus 13 will be 0, 1, 1, 0, 1. So 0 is indicating that the number is positive. It is indicating the sign of number, and 1101, as we know, it is the straight binary representation of decimal number 13. So 1101. So this is how we write plus 13. Okay. Minus 13. How will you write minus 13 now? Minus 13 in sign magnitude form will be MSD bit, you make it 1, and rest of the bit will be 1101. This is what is giving value of the number 13, and this is telling the sign of the number, which means negative. So minus 13, to represent minus 13 in sign magnitude form, you at least require 5 bits, where the first bit will tell the sign and the remaining 4 bits will tell the magnitude of the number. Is that clear?
Yes, ma'am.
Sure. So I'll proceed. Now, I have already told you drawback of this representation, and that is that there are two ways to represent decimal number 0. Uh, the second way of representing signed binary numbers is called one's complement representation. It's complement representation. You have already learnt in the previous class that if we invert each bit of binary number, we obtain one's complement of that number. Okay, right? It means if each one is replaced by 0 and 0 is replaced by 1 in any binary sequence, it gives the one's complement of that binary sequence. For an example, okay, example 1 0 1 1, one's complement of 1011 will be, you just invert each of these binary bits. So instead of 1 we'll write 0, instead of 0 we'll write 1, instead of this 1 we'll write 0, instead of this 1 we'll write 0. So this is one's complement of binary number 1011. So to obtain one's complement of any binary sequence, you just have to invert each of the bit values. So replace 1 by 0 and zeros by 1. You get the ones complement of the number. Okay. So thus the two numbers would be complement to each other, right? These two are complement to each other. Okay. So if one of these number represents positive binary number, the other will represent negative binary number. This is the concept used in one's complement representation form. Okay. As an example, let's say plus 5. So plus 5 in one's complement representation form is written as 0, 1, 0, 1. Okay. Here again, like the previous case, the first bit indicates a sign of number. So you see first bit, MSB bit is 0, it means it is a positive number. This indicates sign. Okay. So 0, 1, 0, 1 is plus 5 and minus 5 in one's complement representation will be, take complement, one's complement of this number. So it will be 1, 0, 1, 0. The MSB bit will be 1. It will automatically become 1 because MSB bit 0 indicates positive number. So when you take invert of that, when you take 1's complement, MSB bit is also going to get inverted. It becomes 1, which indicates it's a negative number. This is sign. It is saying it is a negative number. Okay. So what you get, 1, 0, 1, 0 is representing negative number 5. Yes? Any doubt?
Screen has been frozen.
Oh, yes. Just a second. I will stop again and we'll share the screen again. Yes. Fine. So plus 5 is 0, 1, 0, 1. Minus 5 in 1's complement form is obtained by complementing this plus 5. So we take 1's complement of this. So it is 1, 0, 1, 0. So when you take complement, MSB bit will automatically be inverted, right? All the bits, each bit is getting inverted. So MSB bit, which was 0 earlier indicating positive number, now it has become 1 indicating negative number. Okay. So here again MSB.
Minus 5.
See, to obtain minus 5 in one's complement representation method, you just have to take the one's complement of its positive counterpart. So plus 5 is 0, 1, 0, 1. So to represent minus 5, to write minus 5, you just take one's complement of plus 5. So plus 5 is 0, 1, 0, 1. One's complement of this binary sequence will be, you just have to invert each bit. Invert each bit. 0 has become 1, 1 has become 0, 0 has become 1, 1 has become 0. So 1, 0, 1, 0 is representing negative 5. Clear?
Ma'am,
Okay, ma'am.
ma'am,
Yes.
Can we also represent -5 with 1101?
What you said? 1, 1,
1, 0,
0,
1.
1. No. This is 1101 is sign magnitude representation of -5, right? There you have learned that this is indicating negative number and you find the magnitude of the number from the remaining bits, right?
But ma'am,
1101, yes, 1101 in one's complement representation would mean that it is representing a negative number, and to find the value of this number, you need to take one's complement of this number. Take one's complement of this. If you take one's complement, what you get? If you take one's complement of this, it becomes 0, 1, 0, which means 2 in decimal. So this is 1101 is -2 in one's complement representation. Is that clear?
can you explain again, please?
See, if the binary sequence is 110 number, this is the binary number given. And if it is said that it is represented, it is expressed in one's complement representation form, using one's complement representation form, then the decimal number that this binary sequence is representing is obtained by first looking at the MSB bit, which is 1, which means it is indicating a negative number. Right? So it is representing a negative number, and to find the value of this number, you take one's complement of this. Either the complete sequence or only the remaining bits. One's complement of 101 is 010. Decimal equivalent of 010 is what? It is 2. So it is representing 1101 means -2 in one's complement. Is that clear?
Okay, ma'am.
So to find the value of a number, when it is represented in one's complement form, if it is a negative number, you have to first take the one's complement of that and then find the equivalent decimal number for it. Okay. Let me take one more example. +7. +7 in one's complement representation form. In one complement form, you have to represent +7. So +7 will be, you know that with n equal to 4 bits, what is the range of numbers that you can represent? -7 to +7, right? So we need to use, just a second, my mobile batteries has gone down. Just a second. Do it. Represent +7 in one's complement form. Just a second, I'm just connecting charger to my mobile. So please wait. Yes, have you people done? +7. Hello? Yes, +7 in one's complement form. How will you represent?
Ma'am, your screen is not being shared.
Now?
Yes,
Still
ma'am.
you are
Now
not
visible.
able to see?
Yes, ma'am. Now
Visible, na? Yeah.
Now we can see.
Yeah. So +7 in one's complement form. How will you write? It will be, we know that we require at least 4 bits to represent +7, right? +7 will, with 4 bits, you can represent decimal number from -7 to +7, right? So same thing is for ones complement also. This is the range. I will come to it later on. So you require 4 bits actually. And how will you represent 0, 1, 1, 1? So the MSB bit is 0, indicating that it is a positive number. And 1, 1, 1 is the binary equivalent, the binary equivalent of decimal number 7. So this is ones complement representation of plus 7. Minus 7 on the other hand, if you want to represent, it will be, you have to take ones complement of plus 7.
Ma'am, your screen is not visible.
Ma'am, your screen is invisible
Yes,
right
ma'am,
now.
your screen
Oh,
is
is
not
it?
visible.
Just a second. Now,
No, ma'am.
No, ma'am.
not just.
Yes, ma'am. Now visible.
Okay, okay. So minus 7, if you want to write in ones complement form, how will you write it? You just have to take ones complement of plus 7. Take ones complement of plus 7 means 0 will become 1, 1 will become 0, this 1 will become 0, this 1 will become 0. So 1 triple 0 is minus 7 in ones complement form. Let's say plus 15 using 8 bits. Let's say you want to represent plus 15 using 8 bits. How will you write plus 15? Plus 15 means 0, 0, 0, 0, 1, 1, 1, 1. So the MSB bit is 0, indicating positive number. And if you take value of this, if you find value of this remaining bits, it will be, 1, 1, 1, 1 means 15, right? So this is plus 15 in ones complement form. Ones complement representation. Okay, and minus 15 in ones complement representation is using 8 bits will be, you take ones complement of plus 15. So it will be 1, 1, 1, 1, 0, 0, 0, 0.
Ma'am, can you please explain again the the plus 7 1 in one's complement form?
Okay,
Because it's
plus,
0 triple 1, right? So 0 triple 1 should
right.
be inverted, right, for one's complement
So
form.
0, 0 has become 1, and wherever there is 1, it has become 0. So it is in inverted
Yeah,
form.
so, but okay, plus 7 in one's complement form will be then 1 triple 0, right?
No, no, plus 7 in one's complement representation will be normal 7 only, binary sequence 7. 0,
Okay.
1, 1, 1. Only thing is we
Hmm.
require 4 bits. The MSB bit has to be 0.
Okay.
The
Okay.
problem was how to represent negative numbers. Representing positive numbers we already knew,
Yes,
right?
understood, ma'am. Understood, ma'am. Yeah.
So plus 15 is like this, minus 15 is this. I suppose this is also clear to all of you. Any doubt in this? So we'll quickly see the range of numbers that can be represented using this ones complement representation also. Now you see here, this kind of representation also face the same problem. How will you represent plus 0? 0 in ones complement form. You see 0, 0, 0, 0 if I write, what will you say? What is this representing? This is representing 0 plus 0, right? Because MSB is 0 and the value of this number is 0. So it is representing plus 0. What if I write 1, 1, 1, 1? What is this representing? If I say this is the binary sequence in ones complement representation form, what is this representing? It is representing
Plus 15.
no, it is
Minus
representing
0.
0.
Minus 0.
MSB is 1. It means it is indicating negative number. And to find the value of this number, you take one's complement of this. So one's complement of this is 0, 0, 0, 0, right? 0, 0. Take one's complement of this remaining bit. It is 0, 0, 0, which means decimal number 0. So it is representing minus 0. Right? So this representation also, this form of representation also faces the same problem. It also has the same problem. That is, there are two ways to represent number 0, which has no meaning. Plus 0, minus 0, it means same. It has, if one code word is sufficient to express number 0, right? But we are wasting one code word unnecessarily. So there are two ways to represent 0 here also, and therefore the range of numbers that can be represented using n bits will be from minus 2 raised to n minus 1 minus 1 here also, because we have minus 0 also. One code word is used for representing minus 0, right? 2 plus 2 raised to n minus 1 minus 1. Again, this minus 1 because we are using one code word to represent plus 0. So the range is from minus 2 raised to n minus 1 minus 1 to plus 2 raised to n minus 1 minus 1, similar to that of what is, for what we have seen for sign magnitude representation. Okay. So this is clear. So that's why I said when you have to represent plus 7, we cannot use 3 bits. Although we know that plus 7 in unsigned binary form can be represented using 3 ones, right? Triple 1 is 7, you say, right? But when you have to represent plus 7 in one's complement form, you require one more bit. Why? Because the range of numbers, if you use only 3 bits, the range of numbers that can be represented using 3 bits will be minus 2 raised to power 3 minus 1 minus 1, 2 plus 2 raised to power 3 minus 1 minus 1, which means minus 3, 2 plus 3. So if you use 3 bits, you can only represent numbers from minus 3 to plus 3. So plus 7 is not falling under this range. So to represent plus 7 in one's complement form, you at least require 4 bits. Am I clear? Is this part clear to all of you? Yes?
Yes, ma'am.
So I will very quickly go to the third form of representing signed numbers, and then we'll stop. The third method is called 2's complement representation. 2's complement representation. So in 2's complement representation form, the positive numbers are exactly the same as in other two forms. Negative numbers, however, is represented by the 2's complement form of the original number. So in order to represent negative number in 2's complement form, as I said, you have to take the 2's complement of that original number. Now, first of all, let us understand how to calculate 2's complement. Okay. Let us say you have been given binary number 0101. Okay. This is the binary sequence. To find 2's complement, you have to find 2's complement of this number, let's say. Okay. 2's complement of 0101 will be, how to do it? First, you take the 1's complement. Okay. 1's complement of this number will be replacing each digit, inverting each digit of this binary sequence, right? So 0 will become 1, 1 will become 0, 0 will become 1, 1 will become 0. This is what? This is 1's complement, right? This is 1's complement of this number. And then you add 1 to the 1's complement. What I am doing, this is the number given, okay? This is the number whose 2's complement you want to find out. So you first find the 1's complement of that number and then you add 1 to it. So when you add 1 to it, what will you get? 0 plus 1 is 1. This will come as it is 1. This will come as it is 0. This will come as it is. So this is the 2's complement. Is this clear to all of you? How I have found 2's complement of given binary sequence? Yes?
Yes, ma'am.
So to find 2's complement of any binary sequence, you first have to find out 1's complement and then you add 1 to it. Okay. So one more example, let's say 10110 is the binary sequence. So to find its 2's complement, what we'll do? First step is,
And we can't see.
Sorry. Now
Can't
is
see.
it visible now? Now visible now? So to find 2's complement of this number, what we'll do? First step is find the 1's complement. First step is find 1's complement. Okay. So 1's complement of this number will be, tell me quickly.
1, 0, 0, 1.
Yes, 01001. Okay. So 2's complement will be, you add 1 to this. So 1 plus 1 is sum 0, carry 1. 1 plus 0 is 1, 0, 1, 0. So this is the 2's complement of number 10110.